Hi, so this video is going to be about axes intercepts. So remember we talked about axes being the plural for axis. So we're talking about more than one axis. And intercept, think about where things cross over one another, where they meet, where they intercept, where they intersect, if you were. So we've got two, obviously. We've got the x-intercept, and that is the x-coordinate of the point where the line cuts the x-axis. So wherever that line, in the example below, we see the red line crossing over the x-axis. So in that case, this would be the point where it crosses the x-axis, so that would be the x-intercept, the x-intercept. So the y-intercept is the point where the line crosses the y-axis. So again, y-axis is vertical, so that point where it crosses would be right there. Okay, great, that's it. That's all there is to it. So it's just the point where that line crosses either the x or the y axis. So the example here wants us to find the x and y intercepts of the line given below. So again, we're just indicating where that line crosses the x-axis. So the x-intercept, the point where that line crosses the x-axis is at 2. And the y-intercept, where that line crosses the y-axis, is equal to -3. So those are not the coordinates. So the intercept is not looking for the coordinates. It's just looking for the x-coordinate if you're talking about the x-intercept, the y-coordinate if you're talking about the y-intercept. The coordinates of this point are 2, 0, and the coordinates of this point are 0, -3. So what you'll notice is the y-intercept is the x-coordinate when y is equal to 0, because we haven't moved vertically at all. We haven't moved off of that x-axis. So the y-coordinate is going to be 0. Similarly, for the for the y-intercept, x is equal to 0 because we haven't moved horizontally at all. We are still sitting right on that y-axis. But when you're asked to find the axes intercepts, you're just looking for a single number, okay? So another way of looking at this kind of question is if you are given the intercepts and then you're asked to draw the graph, and then in this case, you're also asked to find the gradient. So we start by drawing the graph. So we're gonna draw our axes with a ruler, not like I am doing. Okay, so we've got our x and y axes drawn. So our x-intercept is -2, so that line crosses the x-axis at -2, so there. And then our y-intercept is -3, so it crosses the y-axis at -3, which would be there. So to draw the line, you're going to always use a ruler, not like me. And you're going to put arrows on both ends indicating that that line goes on forever in both directions, and it must cross through the two axes intercepts that you've illustrated. So then to find the gradient, we're sort of graduating from the counting method. We want to sort of default to always using the formula. So m standing for slope, y2 minus y1 over x2 minus x1. So in order to use this, we need to know two coordinates. So the coordinate of your x-intercept is going to be -2, 0, and the coordinate of your y-intercept is going to be 0, -3. So those are the 2 points that we're going to use. So again, to use this formula, we're going to label off one of the points as point 1, so x1, y1, one of the points as point 2, x2, y2. So then we just plug those right into our formula. So y2 is equal to -3, y1 is equal to 0, x2 is equal to 0, x1 is equal to -2. Okay, so then Solve top and bottom. -3 minus 0 is just -3. 0 minus -2 is +2, so we get a final gradient or slope of -3/2. Now that makes sense that that's negative because as we read that line left to right, we're going down. So a negative slope would make sense in this case. Okay, and that's all there is for axes intercepts.